This is the Amp Hour Podcast, released October 30th, 2022. Episode 607. The Joulescope Upgrade with Matt Liberty. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Matt Liberty, the creator of Joulescope and owner of JetPerch LLC.
Matt, how are you?
Doing well. Great to be back here on the Amp Hour.
Yeah, you have a new product. This is the Amp Hour is the place for product launches, and that's a slogan I just came up with. Product launches for all of your electronic measurement needs. You have a new version of the Joulescope.
I do, yeah. We have the next generation. We've taken everything that we've learned from our original product, which was the JS110, and incorporated that great feedback into our new product that's launching on November 3rd, 2022.
November 3rd. Wow. That's awesome. Could you give us a little reminder about, so people who didn't hear the last show, we will link in the last show, which I don't remember the episode number. I should have had that up in front of me, but we'll link that in the last time you were here. What is the Joulescope and what's it meant for?
So modern electronics has a huge dynamic range of current. So a lot of times they'll go to sleep and consume microamps, sometimes even nanoamps,
Yeah.
and then turn on and often do sensing and radios, whatever they need to do at milliamps or even amps.
Okay.
And that high dynamic range is very challenging to measure accurately. And also, as you're designing a product, making sure that your overall energy consumption is as low as possible so you get long battery life is really challenging. The Joulescope was designed to help with that. It measures current and voltage and then computes power, energy, charge. And from there, you see either like a multimeter view or a waveform view of your consumption over time, which allows you to measure and then optimize so you can produce an awesome product.
Yeah, and it is a headless unit as well. I think that's also an important feature to mention, so that there's no screen, but your computer is your screen, and that's makes it even easier to script with as well.
Oh, definitely. Yeah, it's one of the family of USB connected devices. So I'm a huge fan of Salier Logix stuff as well. So it's in that same family of you connect it up to your computer, you have something running on your PC or Mac or Linux machine that talks to it, and we have a GUI that you get out of the box, or you can script it freely with Python, and we provide all the stuff to do that.
Awesome. And how do you see, how are most people using this? Are they using it in production and test and new product introduction? Where are people using it most often?
Actually, all over. So there's a lot of people that are using it during the design phase, either as firmware engineers or hardware engineers. We have some people that use it, actually quite a few people that use it as part of their automated test. So with hardware in the loop, you push up your changes, you run whatever tests you would normally run, and as part of that, you also measure your current or energy consumption. And that just goes into your record and metrics over time. We have people that are using it on their factory. Actually, I use my own Joulescope on the factory to manufacture.
Bootstrapping, yeah.
We have people that use it for scientific as well, which I wasn't really expecting out of the gate when we launched the JS110. But the JS220 is even better for that. It's much more of a stable scientific instrument, and we've taken the time to make sure that it will work well, not just for people developing products that you're measuring the typical LDO or switch mode power supply into your device, but for really any general purpose voltage and current measurement.
Oh, interesting. So like they're using it maybe like to monitor an experiment?
Yeah, so there's some people, there's very expensive equipment that measures nanoamps that's out there. For a lot of experiments where you need to measure nanoamps, Joulescope, it's not going to be the same, solid metrology of something that goes down to picoamps, right?
Yeah. I used to work on that kind of stuff.
Exactly. But as far as measuring, nanoamps and tens of nanoamps, especially if you remove the slight offset that the JS220 and 110 have, you can actually get a very good signal with much higher bandwidth than a lot of that other equipment.
Yeah, and it's also not going through GPIB or HPIB.
Right. It's a nice USB interface with Python, or now with the JS220, it has a C level driver, so we can eventually hook it up to any language pretty easily.
Scientists love Python, so that's
I'm with them. So I do a lot of C, a lot of Python, and my productivity in Python is way more than with C. It's not going to be as optimized or run as reliably necessarily, but if you want to just get something done, Python's awesome.
Yeah, that's great. Well, that's awesome for our listeners. I think a lot of them will probably resonate with, a lot of that stuff, test and experiments and things like that. Do you think is it an everyday driver like on the bench sort of thing, or like what stage? What is the earliest you see people using this in product development?
So the classic answer of it depends.
Of course,
So
of
I mean,
course.
if you're building up a lab, is the Joulescope going to be the first thing you buy?
Great,
No,
great
no,
question. Great
no.
question.
I would not recommend it. Before you buy a Joulescope, you should have a multimeter. I mean,
Hmm.
even if it's a little $30 multimeter, you should have at least an inexpensive oscilloscope. One of the Regal or
Yep.
Saley Logic is another one.
Yeah, we talked about that on the show last week actually about like where is that level? Yeah, that makes sense.
Yep. And then if you're doing something that involves power, the Joulescope might be the next thing there. If you're talking about getting battery life, long battery life out of your product, getting optimizing your code to be nice and tight so it is not consuming excessive battery, or even just selecting the right battery for your product. The Joulescope might be that third thing. There's certainly a lot of other demands that you might want ahead of the Joulescope, because electricity and designing products is all about making sure you can actually see or measure what you care about. We can't see electrons, or well, I can't. So you really rely
Keep
on your
trying, man.
tools.
Keep
I
trying.
keep
You'll
I
get
keep
there. You'll
squinting.
get there someday. Yeah. Okay, that's great. And so you'd say even before a power supply as well. This could be your
Depends.
power supply.
Yeah, so I mean, it depends on what you're using. So if you're just using batteries to do a lot of your development and a rechargeable, for example, you
Yeah.
may not even need that if especially if you're a software developer that is getting hardware from your team or off the shelf hardware. But yeah, I mean, there are certainly other things that are up there. So bench supplies, signal generators, frequency counters, all these type of things, or just an analog discovery. One of those, the digital and analog discovery, is also a
Yeah.
great way to get
One
a
of my
lot of that
favorites.
stuff.
Yeah.
Yeah.
Yeah. That's great. Okay. Yeah. So that sounds great. So it's maybe not your first or second instrument, but it maybe is your third or fourth. And it does sound like as well, like the target market as well. It's like if you're doing analog, analog only, this could work for you, but it might not be exactly what you need. But it sounds like it's really that high, like you mentioned at the beginning, the high dynamic range. That's what I think about is like I'm working on a, cellular IoT thing. It's sleeping most of the time. It wakes up, it's drawing amps, or hopefully
Hmm.
not, but in hundreds of milliamps during transmit. It's like, all right, I want to know that, and then go back to sleep, right?
Yep. Yeah, if you're just working on the analog design side, typically those are pretty constant quiescent currents when they're on. But a lot of times those are part of sensors, right? So your analog chain may be measuring a sensor that's transmitting data up to the cloud or over the network. So that whoever's doing the larger part of that may be very interested in something like measuring the high dynamic range current. But if you're just the analog designer, maybe not as much.
Hear that, folks? Matt said just the analog designer.
Well, I
Past
do.
Chris is so sad. Past Chris is so sad. Luckily, I'm not just the analog designer anymore. I'm also the bad firmware engineer. Uh,
Well, I'm the bad analog engineer, but I keep
yeah, no,
trying.
I'm also one of those these days too. No, that's great. That's a really good rundown. So, well, let's talk a little bit about the hardware. So, what has changed between the 110 and the 220? It's doubled in number.
It's twice as good.
Twice as good, yeah. Somebody's working hard at the Joulescope the Jet Perch marketing department is really thinking through it.
That's what's a problem with having engineers in charge, right?
Well, eventually you start having to, eventually if you have enough revs, then you start running out of digits, right? Just because of the exponential growth.
Hey, I'll be happy to run out of digits. Yeah, so we've actually made not really one major change to it, but it's really a bunch of changes that together all add up to a totally different level of product. From the beginning, we go from a 14-bit ADC that has 12.1 effective number bits ENOB up to something that has 16 bits with 15.1 effective number bits. So that's over an 8-time improvement in just our ADC side. We've improved the analog measurement chain, so the filtering and our amplification, so it behaves awesome now. We had some artifacts that if you hit it really hard, the front end op amp in the JS110 had this super weird pattern because it was a chopper op amp that wasn't totally well designed for the bandwidths that we were interested in.
Mm, yeah.
We've now been able to address that. Overall, we've improved the power supply side, so we have lower noise. We have more processing on board now, so we've upgraded the FPGA to a Lattice ECP5, which I know a lot of your listeners are probably happy to hear. It's an awesome FPGA, and we can do a lot of the processing there rather than shipping it all off to the host now, which helps with a lot of the features that some of our customers have requested.
Yeah.
Overall, we have a better host side solution as well. We've gone all in on publish subscribe. So that just makes the software architecture so much cleaner. We still have an adapter layer for our old, Python interface that everyone has been using. But if they want, they can move to the lower level. It's still Python or C, PubSub access for the device.
Huh. And so, what is the pub sub like manifest as? It's like instead of having like was it polling before or what was going on?
Yeah, so before we had essentially data coming in on USB bulk in, and then we had parameters, but a lot of those parameters were being processed on the host side and then sending up these more complicated messages to the device, which made it less flexible for us to add new features because every time we had to do something, we had to change those messages, and that just got difficult to manage over time. Now we have actually the device itself processing PubSub in firmware. So we have topics and values that are starting on the host and getting sent down to the device, and then the device just handles each one of those. So adding a new
Oh,
control,
interesting.
a new thing, just becomes
So now
super
you have to
easy
like
now
push a
because
change to the firmware to just be like, oh, now you're also listening for, trigger 52 or whatever it is, and then it just starts listening for it.
yeah, and it's actually even easier than that, in that the device advertises which topics are available. So it has this metadata that it also provides to the host. So there's really no changes that are necessary on the host to add a new control.
Oh, cool. Okay. And then so then the device, sorry, the host side publishes or the device publishes.
Well, they both can. So
Okay.
if something changes on the device, it can publish that something changed. But normally with these type of controls, the host is changing how the device is behaving. So it
Aha. Okay.
publishes and it goes to the device. The device does whatever it needs. It may actually reply with things. It may cause it to start sending out data on
Uh-huh.
that, like current data or voltage data, whatever, depending upon what parameter you just set. So there may be side effects to that publish, but sometimes it may just be changing the current range. So if you want to set it from auto to 10 amps or 18 microamps, you can do that from the host using one of these messages.
Cool. That's really cool. And so then are you running so you have an ECP5 on here. You got
Mhm.
a bunch of I'm sure custom logic in there. Did you also put a microcontroller inside that or is it just all in logic and just doing like streaming?
Yeah, we actually have two parts to this. There's a microcontroller that is Cortex M7. It's a SAM, so formerly Atmel, now Microchip S70 chip that is doing the USB communication, really just shuffling data around. That's its
Yeah,
main
yeah.
role in life. And then on the FPGA, we actually have a RISC-V processor,
Ooh.
little teeny Pico RV32.
Oh
Um,
yeah. Claire Wolf's
yeah,
original design, right?
exactly. Yeah. So I
Yeah.
actually looked into a few different cores. So Bruno Levy has a great series of learning FPGA cores. There's some higher end cores, but I found that none of them were doing that great as far as cycle, memory accesses and cycle on the ECP5. And the Pico RV32 did well enough. I almost got to a point where I wanted to put more processing on that and started writing my own before I realized I really didn't want to do that.
Well, at least you stopped. Most people realize that like 2 or 3 years down the road when they're in like support state, and they're like, "Oh wow, yeah, that was a bad idea."
Yeah, so instead I wrote my own custom processors. So,
Ah,
win
yeah,
or lose, no.
yeah.
So we do have actually a couple of custom processors on there where they really are processors, but specialized ALUs
Oh, cool.
and running our own assembly language. And we have Python assemblers. So they're super simple. These are nothing that you would write home about. But the thing about when you write your own little processor is you can design your own instructions, and things like our calibration, which we're doing at
Oh,
36-bit,
yeah.
and then accumulating statistics, which we do at 100-bit, which don't
Oh,
work really well at RISC-V instructions
right,
on a
right.
little ECP5. We can do pretty efficiently with these just little custom processors.
Oh, that's cool.
Yeah, it's not that hard to write them once you kind of get your mind around. You're just writing a state machine.
Yeah.
If you're coming from the hardware world, all you're doing is writing a state machine. It's just the states are the instructions,
Hmm.
and you just have to put the instructions in the right order, and you just have it pipelined, and the pipeline comes, free when you start thinking about this as a processor rather than as a state machine.
Matt Liberty explains processors, which is it's just a state machine. You just got to put it in the right order. There's a pull
That's all
quote.
it is. The
Yeah,
entire the entire 60 or whatever years
that's
of
right.
computing.
What up now, Noise? That's great. That's cool. So what is the workflow like for doing ECP5 stuff? Is it all Verilog and then like the open toolchain stuff?
Yeah, so what we've been using is Verilog for the language, CocoaTB, and Icarus Verilog for simulation. And I looked into using the open source toolchain and would love to use it. At least when I started on this, there was enough challenges with some of the things like the Mac, which is obviously
Yeah,
really
real
important
important. Yeah,
for what I'm doing.
yeah.
So
Multiply accumulate is kind of your jam, I'm guessing.
it's pretty important. So there were problems then. I think a lot of those have been worked out, but I haven't really
Oh yeah,
reinvestigated. Yeah, so I'm still on the Lattice official tool chain.
right.
They're
Because
diamond
if it
tools.
well, and a lot of the yeah, because that's the kind of thing where they had to reverse engineer a lot of that, right? And I think
They did. It's
yeah,
awesome. I mean, it's cool work.
yeah,
Yeah,
yeah.
it's pretty impressive.
Yeah, but I can imagine that. Yeah, for a you just need to make sure it's working as it is as it intended. So yeah, that's cool.
Yeah, no, and it works well. I would definitely like to have the open source tool chain behind it, but
Okay.
we're not there today.
Yeah, cool. And then on the Atmel the dual core M7, are you doing like an RTOS on there, or what's actually handling all the USB stuff?
Yeah, about that, we do have an RTOS. It's actually a custom RTOS now.
Oh
So
no.
And I started out with FreeRTOS because I've done tons of projects in
Sure.
FreeRTOS.
Yeah.
And I looked at Zephyr as well. I know that you've been playing with Zephyr quite a bit.
Yeah. Atmel support's not great though. I think it really depends on
Yeah.
which hardware you're. It comes down to hardware support, right? I think in the free RTOS space too.
Yeah, oh, both of them came up and ran. The problem with both of them is that I'm trying to push data super fast over high speed USB and interrupt latency and interrupt latency and interrupt task switching time. So the time to go
Yeah.
from the interrupt or from whatever you're doing into the interrupt and
Yep.
then from the interrupt back to your task is super critical for this.
Yeah.
And I was running into problems just where a huge amount of my time in the microcontroller was being taken up by those task switches.
Mm.
So I ended up just writing this super small, very efficient little RTOS. It's not even an RTOS; it's a tasking
Scheduler.
library. Yeah, it's a scheduler. Exactly. It's
Yeah.
it's nothing fancy,
Yeah.
but it is super fast and small. So that's
Yeah.
why ended up going that way. And it's tailored for this particular chip
It's cool.
to get the most out of it, and that's just enables us to push data super fast over USB.
Yeah, I think that's the kind of thing where like you're at the edge of performance type stuff and you're trying to get that extra efficiency. I think that's usually when custom logic in an FPGA and custom RTOS. That's the kind of next level stuff that you need. That's when you need to do it. I think the problem is some people start there because they just want the control from the beginning. It's like, well, if you're just doing that, like if you're just doing simple tasks, then you probably could pull an off the shelf RTOS or similar. Well, like you did with like your choice with the Pico RV, right? You
Mhm.
eventually you scale it back. You said I could do custom, but you scale it back to something that's out there and supported. So I think that's always the trade offs.
Yeah, definitely. If you can find something off the shelf that works well enough, and like with the Pico RV, instead of putting more stuff onto that, I
Hmm.
made these custom processors, which ends up being a better architectural decision anyway.
Oh, interesting.
If you can figure out ways of using the existing stuff and just not loading it, that's great. In the case of my interrupts, it was really hard to back off on that interrupt requirement because we had to service real it's the USB is not so bad because we're just DMAing everything out, but it's the coming in from the FPGA, we're using this kind of dual SPI configuration and it just requires a lot of interrupt handling.
Yeah, that makes sense. The thing that always comes up in my mind is the support load on this sort of thing is higher, right? Because I'd imagine you have to make sure that it's manufacturable. If the part changes, we'll get into the manufacturing stuff and that sort of thing in a bit here. But like Is it still just you? I mean, on the code, are you bringing other people in, or what's the support side?
So on the engineering side, it's mostly been me. I've gotten a little bit of help along the way, but it's still pretty much been a one person engineering development effort.
Impressive, very impressive, very impressive. Yeah,
Thanks. It keeps me on my toes for sure.
yeah,
So doing everything from the gateware to the microcontroller firmware code, and then the host code, and then dealing with all the business issues you have to deal with. Yeah, so the engineering side has been mostly me. I've gotten some review and feedback from other teams. Obviously, I rely on thousands of people, I think, in order to actually manufacture this. The chips, everything from chips and boards and all the other mechanical parts, my contract manufacturer, actually still working with my wife who does all of the accounting and shipping and
oh
a
yeah,
lot of the all the business side of things that keep our business running every day. She's
yeah.
responsible for that. At one point, I'd hired some marketing help. Harris Kenny
Oh
was
yeah,
was
Harris is
yeah,
great. Yeah,
yeah. No, he was doing a great job, and then the component shortage really kicked in, and I'm like, I don't know if I can build anything, so I scaled all my marketing back to
yep,
zero.
yep, yep. Harris and Sean Hemel were the ones doing Hello Blink show, and people have
Mhm.
probably heard us refer to that in the past. So,
Oh yeah, and if you want to reach out to him, I think he's now doing inbound lead generation and
hmm,
outbound lead generation. He's
yep,
been
yep,
great guy.
yep, definitely awesome. Well, that's good. The reason I had an agenda here. I was going to talk about the hit by bus test. Like that's I always think about that as a resilience in the business thing.
Mhm.
And the only reason I really bring it up is because my software engineer literally got hit by a bus. Like his car got rear-ended by a bus,
Oh
and
man.
thankfully he was okay. But I was just like, oh my god, this is like this is the same thing, and it's just like wow, like that totally can impact businesses.
Yeah, so the one thing that I have done, so obviously the new product stuff has all been, without me, it would definitely stall.
Hmm.
But with both the JS 110 and with what we're doing now with the JS 220, I'm fully turning everything over to my manufacturer, my CM. They don't need me to build anything. Well, other than purchasing parts these days. They used to do that. Now, I'm doing all that, which is all
Uh-huh.
fun, but they can actually continue to produce and service customers.
Oh, that's great.
The technical support side with the JS220, I'm doing a better job right now of trying to build up more of a knowledge base that we can hand off to other people and help grow the company. One of the things
That's
that
great.
we really value is customer support. It's a huge amount
Yeah.
of high priority for us, and a huge level of importance. But right now I'm doing almost all of that is on the technical side. So
Yeah.
finding someone else to help out so we can give even better support and more round the clock support for our customers everywhere is a priority.
Is that something you want Amp our listeners to write in about if they're interested?
If they're interested, yeah, certainly. So we're
Okay.
looking for at least one person that would be interested in helping to build up a community and answer questions as they come in. We don't have that many, so this is not a huge job.
Sure. Sure. It'd be like part time kind of gig.
Oh yeah, it's a part time, but it does require someone who would be interested in learning and figuring out how customers are asking questions that aren't always the what you need to answer. This is a typical FAE thing, right? Figuring out what the customer is really asking, not what they are saying.
Yeah. Oh my God. Yeah. Yeah. Right. Right.
Because everyone kind of comes at things from their own perspective. So it's a huge part of the first part. Just the question they asked might not be the question that will help them get to where they need to be. So, working through that part of the communication cycle.
I saw a thing about that recently. I read in that space
Mhm.
as well, and it was like it was an example. I forget where I saw it. So apologize if someone sent this to me but it was like the person was like on a forum saying, I really need to be able to extract the last three characters of a file name. And they're like, okay, well, what are you really trying to do? And they're like, I just need to find the last three characters of the file name. They're like, all right, well, here's how you do that. But before you do that, what are you really trying to do? They're like, well, do you need the extension? And they're like, yeah, actually, I do need the extension. They said, well, the extensions aren't always three characters. You do know that, right? That's a bad test. It's like one of those good examples of like
Mhm.
that they think that that's what they need, but it's really about like zooming out and be like, no, what are you actually trying to accomplish here?
Yeah, that's huge. If it's really all of what we're doing as a company, we're trying to solve real problems, and the real problem that we're focusing on is helping people develop, low power and energy efficient products. So people come to us with all types of questions of how do I optimize this little part of code? It's like, well, I can help with that, but what is the real thing that you
Yeah,
want to get?
right,
So
right.
it's a very common thing because it's just human nature. We get very focused on the
Oh,
problem that's
interesting.
facing us and ask about that rather than the larger thing that is really the challenge that we're facing.
Yeah, I would think that would be actually additionally challenging too because they are trying to get lower power on their devices, but that doesn't really to be a bit blunt about it, that doesn't help you make money, right? I mean, like you are selling devices and you want to support those devices, but like if it's outside of like the actual device itself, the JS220 or the JS110, like that's kind of on them. But I'm guessing they all ask for help in the broader context of saving power.
Yeah, I mean, we have, we're very lucky in that we have a great set of customers. For the most part, we have people that realize that they want to do this, right? That this is a self-selecting group of
Yeah, right,
people
right.
that are
Not someone
trying
coming
to
off the
design.
street.
Exactly. These are for the most part, we don't get people that are just learning how to use a multimeter, which is fine. We have had people like that, and then which is awesome. But for the most part, our customer base is pretty well informed, so we don't have to do a lot of that education that a lot of other companies may need to do. So yeah, we do get questions that are not as as well formed, but for the most part,
Well,
that
wow,
people
Matt should run for office at some point. That was a very nice. That was a very nice turn of phrase. What Matt's
no,
trying to say is some people ask some dumb ass questions. I'll just say it for you, man. It's cool. It's cool.
it's
That's what
all
I'm here
good.
for. As someone who's
No,
probably going to ask some dumbass questions in the remainder of the show.
no, it's awesome because we have a forum where people can ask questions
Yeah,
publicly. We have our GitHub repos where people make bug
yeah,
reports,
that's good.
and then private communications as well. So we get all types of great feedback and customer you know opinions across the whole range of our customers, and it's really cool.
That's great. That's great. Cool. Well, let's see. So far we've talked about. I've alluded to manufacturing. I do want to get into manufacturing. Is there anything else we need to do on the before we do that? So we'll at the end of the show we'll give some contact info if people are interested in the support side of things. I would imagine and like helping out with that sort of thing. I would imagine someone who is younger would be able to learn a whole lot. I don't know what age group or experience level you're looking for, but I imagine a younger person with some background knowledge in this space could learn a whole lot about a whole lot of interesting things at Joulescope.
Yeah, definitely. I mean, again, this is not a huge role, a couple hours a day type thing.
Mm-hmm.
But yeah, it'd be awesome to have someone who's just super eager to jump into different questions. I mean, it could be a role where you actually create examples as well, if
Oh
that's
yeah, yeah,
interesting. It doesn't have to be, but we have a whole repo of examples that a lot of them we built for customers, specific questions that we've gotten asked. So something like that would be part of it, possibly.
yeah,
Again, this is super flexible because we're a super small company
yeah,
and
yeah.
really can match things up to what people are interested in.
Yep. Well, let's dive into the manufacturing part because you have had a heck of a time with part shortage. But I have to say, it's I think I saw someone mention just the fact that you're getting anything out right now and that you have ECP5s on this board are their own level of amazing here. So let's what were some of your challenges, Matt?
It doesn't feel amazing. It feels more like I have a blunted forehead from bashing against the wall. So for those that don't know, and if as an Ampower listener, I think you already know that there's been a component shortage for the last 18, 20 some months
Yeah.
that has pretty much dampened the entire industry. So I was producing JS110s. This is we launched it from Kickstarter in 2019 in July, and my normal process was like 3 to 4 months before I wanted more JS110s. I'd tell my contract manufacturer, build me more JS110s, and they'd go
Hmm.
out, order parts, get them all in, put them on boards, put them in the enclosures, put them in my carry case, and I'd get completed boxes of 10 each that we would then sell to our customers. That's great.
Lot size of 10. That's lower than I would have guessed.
Oh no, that's a box size of 10.
Oh, a
So our
box is 10. I
yeah,
see. I see.
yeah.
Okay.
So our typical lot sizes have been about 500 each.
Yeah, that makes yeah, that sounds more like it.
Yeah.
Okay. Yeah, get some volume there. Yeah, that's good.
Yeah. 10 would not be cost effective. So yeah, that was an awesome process. That's normal turnkey contract manufacturing. Well, about February of March of 2021, that all changed. So I was about to start building another lot of JS110s, and I happen to have two parts on that board that are still unobtainable. I ordered them in March or April of 2021, and they still haven't arrived. And
Holy
the lead time
moly.
is, yeah. So one of them is an NXP part, and one is an STM32F0 part that I could probably substitute, but yeah. So both of those have been extremely constrained designs as far as availability. So at that point, I was kind of wondering how much do I push forward the JS10. We had manufacturing challenges with the JS110. They turn out fine, but it's just more of a pain to manufacture them than
Uh-huh.
I think all of us would like. And the
Uh-huh.
JS220 addresses a lot of that. So at that point, I kind of started making the mental flip to do another JS220, push towards that rather than build too many more rounds of JS110s. So we were able to get more parts in for some of those because I'd already ordered them. But our supply ran out in June of this year of JS110s.
Wow.
So I started ordering parts for the JS220 in June-ish or June or July of last year.
Oh my
That
gosh.
was, to put that in perspective, I had just finished the first prototype that wasn't even close to what we have today.
Right. So it was like a true leap of faith and you're like, "Hello, I'd like to put all of my cash into this hopefully working venture in the future."
Yeah, as someone who has a small business, putting
Yeah.
out that much money. I mean, so
I
I,
mean,
I
cash flow
essentially was
is
cash
insane.
flow is
Yeah.
hard. Yeah, it's crazy. And I was fortunate enough that with the JS110, I priced it correctly
Mhm.
so that we were able to do this. I mean, a lot of people getting into hardware manufacturing don't know the pricing of how you really need to price it. So if it costs you $300 to build or $400 to build and you price it at $500, you're going out of
Oh,
business,
your host, yeah.
right?
Yeah.
So a lot of people that critique pricing of products, don't realize just what you have to do in order to stay in business.
Right.
And this is a huge example.
I think also scale too, right? I mean, like, you're talking about buying 500 at a time, but like versus a large scale test and measurement company like that is doing thousands or tens of thousands at a time, and just the scale is just completely different.
It is, but the problems actually only scale up in a lot of ways. When you go to buy parts, I mostly, and well, before in the before times,
Uh-huh.
would buy from DigiKey and Mouser, your
Uh-huh.
normal small volume supply chains. When you start getting to the 10,000 unit volume, you really can't do that anymore.
Yeah.
You're now scheduling your deliveries using, Avnets or direct from the manufacturer. So your challenges about forecasting become
Yeah.
bigger too,
Yeah.
right?
Oh, totally on the challenge on that side, but I just mean that like at the scale you get bigger negotiated discounts, and you also
Right.
have usually better terms on like financing and things like that, because I think about a lot of these companies, like the CFOs are doing so much on their cash flow. Like I imagine like the Keysight CFO, basically they're running a financing organization, right, where they're
Hmm.
like doing their own. They probably have commercial paper they issue and stuff like that, like short-term bonds and things, which is just like completely out of this world for a small manufacturer. Like how would we do that? Like that's insane.
Well, you can get lines of credit and things like that
Oh,
you
sure,
actually
yeah.
can, so
But that's
there
different
are.
than issuing a bond. I think
It
you would agree.
is. It is. But I mean, it's not that we're without tools either. So
Sure. Yes. Right. Yeah. Someone who's like brand new and maybe just like a brand new Kickstarter. That's a whole different. Yeah. That's a whole
right,
different ballgame, right?
you get nothing
Yeah.
other than
Right.
the
You credit
Kickstarter.
cards. Credit cards. If you're
Yes.
if you have good credit personally.
Yep. Yeah, and like with all this stuff, I know there was a talk recently that you did with, I'm blanking on the name, about consulting and getting into consulting. And
Mm.
really, in order to do any of this, to get into consulting, to build up product, you do need money up front, right?
Oh yeah.
So
Yep.
getting that financing, whether it's by just being super frugal and saving, or getting some outside interested investor to help, is critical to being able to launch a product. Kickstarter, the crowd
Yeah.
supply,
Sure. Sure. Yep.
crowdfunding approach as well. All of those are ways of getting cash into your business. But yeah, you definitely need cash as a business. Otherwise, something like the component shortage comes along and you're instantly out of business.
Yeah, totally. Yeah.
Yeah.
So so the JS 110 will never be made again. Is that correct?
That is the current plan because, well, even if I wanted to right now, I can't.
Yeah, right, right.
And so far, no one has come back and said, I need the JS 110 over the JS 220. So we tried really
Oh, yeah.
hard
Yeah.
to keep the JS 220 compatible at the software layer and compatible enough at the electrical layer. So we did some things a little bit different with the JS 220. So the JS 220 has a separate voltmeter essentially input and a separate ammeter input. The JS 110 had this view of power in and power out. So you kind of connected in your power supply to in plus and out plus, or in plus and out minus, excuse me, and then you connected your device under test to out plus and out minus. I think I said that wrong. In plus, in minus, out minus. So it flew through the JS 110, whereas now we just kind of have this independent channels of voltage and current measurement. You can do the same things, but
Yeah, you still need the current to flow through, right? But you don't need to. Yeah.
exactly. And actually, on
Yeah.
the JS 110, it was the minus and the out minus were shorted together. So it just, even
Oh.
though it went through the front panel of the
Uh-huh.
JS 110, it didn't do anything. It was just an
Right.
electrical wire.
Got it.
So by breaking them out, we have more flexibility. But that's something that people just look at the device and it's different, right? So
Uh-huh.
any of those, it's different things we wanted to help minimize. So we actually have a front panel that is the JS 110 equivalent for the
Aha.
JS
Oh, that's
220.
smart.
So
Yeah.
we've done as much as we can to try to make it so that anyone who really likes the JS 110, and we have a lot of people in that group that want to move to the JS 220, don't have a huge hurdle to overcome.
That's good. Yeah. Okay. Huh. And then you had sent me notes as well. What does cable for GPIO mean?
Oh yeah, so the JS 110, we had this little header that you could plug into, and you get two inputs and two outputs. And
Mm.
people were used it for some things, but it was a little bit hard to use for some people, I think, because you just had to figure out you stick wires in it and that's it. With this, we have what most other test equipment manufacturers have, a little cable assembly that you can
Hmm.
just plug right in. And we actually found this place through Alibaba that makes them, and actually all the little ends are labeled nicely. So
Oh, that's nice.
it's kind of cool. Yeah. So they just
Yeah.
did a little heat shrink on each wire end that labels each one. So, and surprisingly, it was not that expensive. So it was awesome to put in. And actually, one of the people on the Contextual Electronics Forum said, you should do that. So that's how that came about.
All right. Well, we will expect our commission check anytime. No, that's really nice actually, because one of the things I feel like with cables specifically, when you have to like when they're labeled at the device itself, it's useful, right? You want to know
Mhm.
that. But then you like, okay, then I go plug a single cable, like a single jumper into that, and I'm like, all right, purple is V plus. I have to remember that, and then I get to the where I'm plugging into. I'm like, what was purple? What was purple again? I'm getting older, Matt. I can't remember these kind of things. So yeah,
Yeah, no, it was super easy actually to get this made. So
yeah,
I've
that's
never
great.
really done a custom assembly, cable assembly like this. Just reached out to a couple suppliers on Alibaba, and the one that I ended up finding is super helpful. I'd like to provide their name. I'll get it here in a moment, and we can put it in the show notes.
Okay, that's great. Yeah. Yeah, I mean, I don't know about your experience, but like when I've been on Alibaba in the past, it was like just find someone that was like kind of close, like photos kind of look like what I was had in mind, and then be like, can you make that just a little different? And then I think the big thing for me was like they wanted some particular format, and I was like, can you just send me a test or a drawing that you like, and I'll just mark it up. And that was like that was the best. That was like super fast for me in the
Right.
past.
Oh
Yeah,
yeah, no, I've had great luck with Alibaba. You definitely do not want to go with the cheapest
that's
person.
right.
Typically,
That's
you want
right.
to find someone that you believe is actually going to do a good job.
Yep. Yep.
But for the JS220, we've gotten the carry case,
Mm-hmm.
the cable assembly, the USB cable, and the aluminum extrusion, actually, all done by Alibaba suppliers.
Oh, interesting. The extrusion. Okay.
Hmm.
What and you I mean you have in the back of this thing assembled in Maryland, so you're still using your local CM. I remember last
Hmm.
time you said they were kind of up the road, right?
Yeah, they're about 15 minutes from my house, so I can't complain. So I was just
That's
over
not
there
bad.
yesterday, picking up more Joulescopes that we're going to be shipping to distributors, working through. We have pretty good yield, but still a few issues obviously that we want to work through
Hmm.
and talking about that. So yeah, it's super easy to have just a contract manufacturer right near you, especially for a product like this because we have pretty complicated manufacturing.
Hmm.
So obviously surface mount is surface mount, through hole is through hole, but when you build a
Wait,
dual
wait, wait,
scope.
wait a second. What is it? Sorry.
So when we build a Joulescope, though, a huge part is making sure that it is working correctly and calibrated. So that's expensive equipment that is not part of a normal CM.
Yeah. Yep. Yeah. And so, do you have like your own test stand there? I mean, you said you test jewel scopes with jewel scopes, which is awesome.
Hmm.
Do you like maintain your own test stand there as well?
Yeah, yeah, we do. So we have really expensive test gear to make sure that we meet our spec and calibrate each unit. So we have two custom stations essentially. One is our programming and calibration test station, and then we have another one that is our final test station that does just a double check because we don't want anything leaving that doesn't work. Just, in manufacturing, things happen. So we have a second
Yeah.
check of performance. And then that's also the laser. It laser engraves the bottom, each one custom, like,
Oh.
uh, like you see. So we get the top part engraved from our aluminum extrusion provider. The
Hmm.
bottom part is custom engraved in Maryland here, and that's a new addition to our manufacturing line, which was
Oh,
kind of a cool purchase.
that is cool. Oh, I didn't realize this was laser. Oh, so it's like black paint over white. Is that kind of how it does the laser engraving?
No, it's actually kind of cool. So this is black anodized aluminum,
Hmm.
and when you laser engrave black anodized aluminum, you get this like silver white color, and that's
Huh.
what you're seeing.
That's
Yeah.
really cool. Yeah, no, it's great because it has. So, like, I'm looking at the unit Matt sent me, which is awesome, and I took apart, so that was nice too. I have my serial number on here, and it's got a barcode, so it's trackable and all that stuff. So that is really cool.
Oh
It's got
yeah, yeah.
CE
So
markings, FCC. That's great.
yeah, so no, it's each one's individually labeled. So if we get a return or if someone has an issue, we can kind of trace it back to make sure that everything was right on our side. For the most part, we haven't had any issues with the JS110 as far as parts or bad things being put into it. Which fingers crossed we don't for the JS220. But if we do, we have that traceability,
Yeah,
which is good manufacturing.
that's great. And was it on your site that I saw like a PLM system, a web PLM system that you're using,
Um, we
or is
we
that
well we
someone
use
else? I
Parts
may have.
Box.
Oh, parts box. Okay, no, I was looking at someone else. Then I sorry, I had seen someone. I had someone who sent me a link recently, and they had thanked their PLM provider, which was interesting. I think maybe they gave them a discount or something. But
Huh.
how's parts box for doing all this stuff? We've had Jan on the show before, and we love parts box.
Yeah, no, I really like Parts Box. We have some particular needs given the component shortage. I think Jan's done a great job of actually improving Parts Box to help accommodate some of those needs.
Yeah, yeah.
But the way I met those needs is just entering all my data in Parts Box and then dumping it down into Python and doing my own Python stuff.
Oh, okay.
So the question of 2021, 2022, 2023, 20 hopefully not 2024 is when can I build something, right?
Yeah,
So I have
right,
all these
right.
orders that may come in on dates that are maybe promised or whatever. So
Hmm.
when can I actually, with all these things that are going on and
Yeah,
parts flying in, when can I build my next lot?
right.
Really, my question now is not when can I build the next lot, but when I could build the third lot from now, which
Oh
is
wow, like that kind of level of forecasting. Because yeah, because you also, I think that's the thing is like it's like a big chain, and you also need to provide. So like if you're shipping stuff to Arrow to have them in stock, no, never mind. Arrow doesn't stock anything anymore. If you're shipping to DigiKey, friggin' distributors. Talk about Arrow and Avnet are banks. They're no longer distributors. They don't hold any stock. I will stand my ground on that one. If you're shipping to DigiKey or Mauser, you have to tell them when they can expect your parts too, right? So that's potentially problematic.
Yeah, and ideally for us, we're always in stock, right?
Yeah,
So
right, right.
if I had the ideal world, we'd never have to tell anyone that when we were having more stock, it would just be there.
Yeah, totally.
And for us to do that, we now have to forecast and be buying parts today really for 18 months out.
That's crazy.
And I thought I was all smart a year ago buying for a year of production.
Hmm.
The world has a way of smacking you back down. So we're now scrambling to think about not this build, not the next build, but and really not the one after that, but the one after that.
Wow. I gotta
because
say that's a lot of cash tied up. If you ever like shut down the business, you'll have, as they sell out that stock, that'll be like a little like annuity for you. You'll just be like, oh yeah, I'm still selling Joulescopes.
hey,
Not making them anymore, but I've been selling them for another 2 years.
if we still have the supply chain shortages, I'll be able to sell them all for profit. So
There you go, bingo. Yeah,
at that one point, it was pretty disheartening. I kind
yeah.
of did the numbers just really quickly, and I think it would have been better for me just to sell the parts that I bought
Oh
and not
no.
actually launch the JS220.
Oh no, that's terrible. Oh man. Then you're just a part broker, man. That's nobody.
Yeah, I
Nobody
know.
wants to be that.
Right now, it's not a bad business to be in as long as you get out at the right time.
Well, and as long as you don't mind selling your soul, that's the other thing.
That too.
What is the price of one soul? Who knows? I feel like I haven't done enough justice talking about the actual hardware here, like so the is the isolated power supply the same as before?
It's a little bit different. Yeah, so it's the
Okay.
same idea. With the JS110, we use this little transformer. It's a Worth transformer,
Mm-hmm.
and
Vth.
yes,
I know. As Americans, we'll never be able to say it properly. We'll be corrected every time by the Germans.
exactly. But it's these super little transformers that do a great job. The original one had just plus and minus 5 volt out. This one is actually has both plus and minus 5 and plus and minus 16. So in the
Yeah.
JS110, we were using another word that I'm not going to say correctly, Cook converter.
Oh, the CUK.
CU with
But
the
the C's got does the U have it at the C has it the little
uh,
hangy dangly on the C, or is it on the
yeah,
U?
yes.
I thought it was Chook. I thought it was
Chook,
Chook.
chook.
Yeah.
I mean, I know I'm not saying it right. So we use that in order to generate the minus 16 volts in order to do the voltage measurement.
Oh, cool. And that's not too noisy, huh?
What? No, on the JS110 it was super quiet. That
Awesome.
actually was really quiet because you have the nice thing about that topology is you have coupled inductors, and they end up making the power output super smooth compared to a lot of other switch mode topologies.
Uh huh. That's great.
Yeah, with this one now, we just have 16 volts plus or minus 16 coming out of the transformer. Just use your normal rectifier diodes to make that 16 volts and plus and minus 16 volts, right? DC rather than AC coming out of the transformer.
And how do I make sure I don't have 15 volts coming out of this thing when I turn it on?
You mean out any of the inputs or outputs?
How do I make my plugged in board not go boom, Matt?
Oh, you're good. No
Yeah.
worries. So
Okay.
uh,
Cool.
so what we end up having is it's an isolated supply. So that gets rid of the boom potential between whatever you plug in on one side and your USB and your computer.
Yeah.
So your
Yeah. Yeah.
computer's not going to go
Oh yeah.
boom.
I wasn't worried about it going boom to ground. I was more worried about it going boom through the rails of my microcontroller that I'm
Yep.
testing.
And the way that the voltage side works is those go right into op amp inputs.
Uh
So
huh.
you're not getting
High
exposed to any.
impedance. Great.
Yep,
Great.
yep,
Yep.
no
Yep.
plus or minus 16 volts. And then the current sensor part is just going through MOSFETs and our sense resistors. So it's a shunt ammeter, which is
Uh
just a
huh.
fancy way of saying we're measuring voltage across resistors.
Yep.
And using that known resistance and the voltage, use almost all to compute current. That's really all that's going on at the front end of Joulescope here. And I say all because there's a lot of nuances to that.
Yeah.
But
Right. Oh, that's cool though. So then the minus 15 basically just gives you more dynamic range on the op amps input, right?
exactly. Yep. Yep.
Yeah.
Yeah.
Cool.
So we want this to be used for 12-volt systems. So ideally 12
Ah.
volt plus or minus 20%.
Yep. Yep.
And that gives us the 15. The JS220 is really 14.5 guaranteed.
Mm-hmm.
Some of them go up to 15, some 14.8, but we
Mm-hmm.
guarantee 14.5 plus or
Yep.
minus now. So this is
Yep.
the one difference is this is a fully bipolar in both voltage and current, making a 4 quadrant measurement device.
Really? Oh
Yep,
wow.
yep.
That's no small feat there. I'm holding a little source meter here.
It's as far as the measurement side, that's exactly kind of what this is. It doesn't
Yeah.
produce anything or consume current.
Right, right. It's not sourcing negative current or whatever it is. Like yeah,
Yep, exactly. It doesn't
yeah.
do any of the power supply or current sourcing or syncing.
Mm-hmm.
But as far as measurement, it is doing that same exact thing.
That's cool. That's great. That's great. Then what is you said the ADC went up to 16 bits. I mean, did you just switch out parts or what was the ability to go up market there?
So one of the things that we want to do is to continue to push this up as far as accuracy. So I think there's a lot of people that are very happy with the JS110 accuracy that we really were doing a great job as far as being comparable to very expensive equipment. I wanted to ideally make it so that we're not just doing very well, we're doing the same as equipment that's more than 10x the cost. So part of that was putting in these ADCs. We also have now 4 channels of ADCs, and that allows us to have a new technology that we've called Enwavify that is allowing us to switch, actually measure through current range switches,
Could
which
I
is
get that word one more time?
Enwavify.
Oh man, I engineers making product names and Wavify.
Enwavify.
Yeah,
TM.
next time you need to name something, give me a shout first. That's great. Sorry, I missed the actual important part here. I'm a terrible podcast host. I'm sorry. I was laughing too much about the name. All right, so four ADCs, and that allows you to measure.
Through current range switches. So one of the problems that
Oh,
a
yeah,
lot of equipment has, and this is not just the Joulescope stuff,
yeah,
but you look at a multimeter. A
yeah, totally.
multimeter, when it switches ranges, it's blank for milliseconds or even more.
Yeah,
Some depending upon the multimeter, they just aren't measuring that, even though you may think it is.
yeah,
And most test equipment has that problem. During a range switch, it's just taking a while to reset the analog path, do
yep,
everything, and
yep,
get to it. With Joulescope, we're trying to measure seamlessly for minutes, hours, days,
yep,
months, right?
yep,
Without
yep.
any loss of data. So it's not like an oscilloscope where you have a trigger, you measure for a time, and then you go blank and then measure again. The JS 110 and 220 are always on streaming, from the start till however long you want. There's no
Mm,
missed data. So as part of that, we have to switch current ranges. So if you go from microamps to an amp, there's really no conceivable way you can measure that dynamic range
yeah,
with low burden voltage and actually measure accurately. You just
yeah,
run out of headroom. So the Joulescope has 20 millivolts of burden voltage. So even if you say, let's measure a million things, great, that takes you down to 20 nanoamps, from 20, or 20 nanovolts. Depending upon how you set your range, that's still not enough to meet what Joulescope has as 30, was it 33 or 34 equivalent bits of resolution.
mm-hmm.
So yeah, with the way we've had this now, as you switch current ranges, we're measuring on a separate channel at the highest range always. And with 16 bits, that gives us enough accuracy to actually measure through and have good
Oh,
data. And we've also done things to mitigate some of the other challenges like charge injection from MOSFETs.
yeah. Oh, interesting. Yeah, no, that is definitely a problem. I think some of it is like the old multimeter paradigm. Like you look at like traditionally how it was done. It was like expecting that you're just sitting in one place and you're just measuring. You're not the dynamic piece is it was something that was introduced more in the microcontroller days. I feel like like that.
Hmm.
It's always been a problem, but it was like it's such a common problem now that this kind of in Wavify is necessary, and that's a great workaround there. I mean, that's so then the highest range is always measuring, but you just kind of like do you annotate that like during the switching time there's not as much accuracy? How do you actually alert to the user that it's that a certain data point might be less less accurate, or is it just kind of like, well, you would have had nothing there in the past, so better than nothing?
Right. Yeah. So we've struggled, to be honest, I've struggled with how to dynamically state performance metrics for this because it so
Right.
much depends upon signals and loads. And for the most part, you can take the static specs, which we do provide, and convert them into reasonable dynamic specs. And the problem that we've always had, and well, every test equipment has, is if you switch ranges, what do you say about that? Most test equipment doesn't say anything. They say, "Oh, we're out of commission. Good luck." Even equipment that's way more expensive.
Yeah, yeah. That's a damn shame right there. Yep. Yeah, that measurement stunk.
Yeah. Now with the JS220, we actually have bounded air, and the
Ah,
the,
okay.
the thing, it's hard to say how that's bounded. So we have a few nice things. I mean, it's going to be less than a milliamp of air during those times of current air, and the voltage range you typically would keep the same. We do have 2 voltage ranges, but you normally aren't switching for most of our applications between those. It's the current ranges that you really care about. So with the current system, you're switching, and within 5 microseconds, you're full on back to the original channel. with some of the higher ones, the 18 micrograms, depending upon your load and system, it can be a little bit longer, but
Yeah.
it's typically within 5 microseconds. So we're not
Oh wow.
taking
Yeah.
a huge amount of time, and that's part of the difference that sets Joulescope apart. We're super fast,
Yeah.
right? So
Yeah.
current
Totally.
range switches, a lot of people talk about milliseconds.
Right.
We're done in microseconds for
Yeah.
switching. Actually, we make the decision in under a microsecond, which is, we have dedicated hardware to do that,
Hmm.
comparators and a separate analog channel that's actually making that happen. It goes right into the FPGA. The FPGA sends, oh, we're doing something, and switches things up. We have a super fast but controlled drive to the MOSFETs to mitigate charge injection problems.
Yep.
And then we're switched and over and running through the analog path because it does take time to propagate through in 5 microseconds or so.
Yeah. I think about like an old multimeter that has like relays basically, and you like hear it
Hmm.
clicking through the ranges, and it's like, oh, there's some time when those,
Oh yeah.
like there's those ranges are switching out. There's also like FETs in the path as well, but like when you hear clicks, it's not that fast.
Right. Yeah. And there's something to be said about good old fashioned relays. They have zero leakage for all practical purposes, and
Hmm.
they have very few parasitics. They have some extra capacitance, but as far as weirdness, other than the switching itself, they're pretty nice.
Yeah,
MOSFETs have
it's just
all
the
these capacitors.
dynamic piece stinks, right? I mean, it's like the
Exactly.
switch off. Yeah.
Yep. Yeah. So MOSFETs, even when they're in there, they have some issues. Then everyone, that's played with MOSFETs for any amount of time says this is super weird. You have essentially these capacitances between everything that just cause some undesirable switching behavior and even just static behavior when you have them in a system. So you just have to, when you're doing precision analog like this, you have to think about that.
Yep. Sorry, I was just on mute, writing down your "this is super weird" quote. I'm gonna probably quote you on that one too. This is no, this is really good. I wanted to bring up like some of the chip makers have some kits that are like about measuring battery, like Power Profiler from Nordic is one that I see a lot recently because I use a lot of Nordic parts, and like and this is just a really good point of comparison here. The price is a huge comparison difference,
Hmm.
and I was mentioning to Matt before the show, like on the scale of like power profile, well maybe on the scale of resistor in line with my power supply, all the way up to you know 5-figure device from Keysight or similar, like there is a spectrum of features and kind of like where the Joulescope falls on that spectrum.
Yeah, so the other solutions that you have people use. So starting with a multimeter, just putting a multimeter in line, measuring current is great as long as you don't need dynamic range. And if you try to measure the low, then it browns out your target device. So that's
Yeah.
if it's a great way to get started, right? If it's better than doing nothing,
Hmm.
right?
Yeah, and I think as long as you like understand where you are in the cycle as well, that's another thing that's important, right? So being able to
Right, exactly.
say like I'm in sleep now or I'm
Hmm.
in transmit now in the case of like a Bluetooth or a cellular thing.
Yep, definitely. Yeah, and then the next step up that people do is put a resistor in line with a oscilloscope. The problem is what are you measuring across? If you touch your ground, is that earth ground to or scope ground to your positive side, resistor? That can cause problems. So there are a whole bunch of problems with doing an oscilloscope if you don't have a true differential probe. If you start talking about a true differential current probe, you're now talking more than Joulescope. So then, like things like the Nordic Power Profiler, they're great as far as integrating into the Nordic IDE and giving you a relative sense. Their specs are, different, not as tight as Joulescope and what Joulescope aims to be. So if you're looking for metrology level, the Joulescope is really the most inexpensive one that I know of. There's a few other
Yeah.
ones that are out there too, but we are able to offer ISO 1725 NIST traceable calibration because we are that
Oh.
level of equipment. When we aim to compare with the equipment that you're talking about, that's 5 figures, starting at 5 figures and going up from there potentially to not quite to the CX 3300 family, which is awesome, but with 100 megahertz bandwidth on current measurement, which is a totally different level of gear than what we're talking about with the JS220. But the
Okay.
price is also totally different.
Why would you need 100 megahertz of bandwidth on current measurement like that? Like, what is the true? Is that just for like true qualification of like new silicon or something?
You would have to be going directly into the silicon because when you have a board, which most of my customers are using to measure not just a chip but a board, you have the bypass capacitance. And just
Yeah,
by
right.
by nature, that bypass capacitance forms an RC filter with whatever else you're supplying power in. So whether it's the cable, whether it's the Joulescope itself, that is limiting your measurement bandwidth
Hmm.
or your system bandwidth. So you end up having an RC circuit with 10, let's say you have 10 microfarads on your board, Joulescope, and if you're measuring like 1 milliamp is going to be in the 1.8 milliamp range, which I think is the 1.1 ohm resistor. So you have an
Hmm.
RC filter that's the Joulescope plus all of your cabling is forming. So that limits really what you need to measure, which is how we picked this bandwidth of 300 kilohertz because that's usually about where things max out for most real
Hmm.
world designs, and you don't want to pay for more than you really need. But in the case of measuring
Right.
directly into a
Right.
chip, yeah, the CX3300 can do that.
Got it. Yeah, and I feel like that all of that stuff, like on that spectrum from DMM up to CX 3300, it's like there are different price points as well, and I think it's just about optimizing for the best one there. And it seems like you said, you're trying to target kind of the use case that most engineers are going to have on their bench, but then also getting into production and being able to do production level stuff on boards versus silicon.
Yeah, and make it super easy to use. So, all you do is plug it in.
Ah, come on.
Oh, I mean that's what this is all about, right? So we
I know.
have
Yeah.
customers that don't want to think about anything. They just want to have an
Yeah.
ideal instrument, which doesn't exist. There's no such thing, right? But this
Well,
is
they probably asked for it anyways on the forum.
exactly. So the JS110 was designed for that purpose. The JS220 we've improved, but the whole idea is you just drop it in, you pull up a really simple user interface, and all of a sudden you are able to see what you couldn't see normally.
Yeah, totally. That's great. What about the software hasn't changed? Pretty similar between 110 and 220?
Right now, it's totally the same. We have a major improvement plan for the UI. Well, actually, I kind of misspoke there. The lower level is totally different. So we went
Mm.
to a total C driver. Like I said, we're all in on publish subscribe. We did that in C so we could actually bind to multiple languages, but we include a
Okay.
Python binding so you can access that same API, the publish subscribe through Python. We also have another layer of that which wraps our previous API, the one that we used with the JS110. So as far as you know, you're running just like a JS110, except you're talking to a JS220. So you have the
Hmm.
option of using the old API or the new one. And our UI right now is using that adapter layer still. We have a planned improvement to go to directly to the new layer, which will also enable us to do a lot of cool things like simultaneous device support, which is a huge requested feature. Like you want to measure the efficiency of something, like your switch mode power supply or an
Oh, yeah.
LDO.
Yeah.
Right now, it's not easy to do that with the UI. You can do it with the Python code, but not as easy with the UI. So we want to bring that ability to the UI, also the ability to compare files that you've recorded with what you're measuring now. So there's a whole bunch of features that we're going to be launching over the next 6 months or so, not right
Hmm.
out of the gate, that will support the JS220, and a lot of those will still work with the JS110 as well.
It's fun that the software's never done, huh?
Yeah, and I mean that's
You just have new projects every time, and you also have software in your FPGA and your microcontrollers, and
software eats the world, right?
I mean, Matt, I am super impressed with this. This is just like so many different layers here, and like I know that you have supporting people, most notably your wife, your CM team, and but like just the fact that you are doing all this stuff is very very impressive.
Well, thanks. Yeah, it's what is a full stack engineer, right?
Yeah, that's right. All the way down to the silicon. Now you're making your own. So what about that? You're gonna go to Matt Venn and be like, hey, I need some custom silicon now too.
That'd be pretty
That's the
sweet.
next step, man.
I
That's
have
the
I
next step.
have believe me, if I wasn't so busy, I would have put something in for his shuttle. But
Yeah.
oh man, yeah, it'd be so cool to have. I know there's some things that we could do on the silicon layer that right now we have to piece together from components, and there's some downsides to that. But I don't know if I'm up for making a chopper amp in silicon that is high precision analog.
Oh, I wouldn't do analog there. I would say maybe one of your little custom processors. If you wanted to break that out for some reason,
Mhm.
that would be the stay
Yeah.
digital for that stuff. Speaking of digital, I wanted to mention the front plate as well. So you have a new test front plate on this thing. So like basically when people buy this thing, unbox it, they can plug in this test front plate. What does the evaluation kit do?
So the evaluation kit is just a little board that is designed to regulate USB power, so it plugs into USB itself, and then wiggle signals. So without any effort, you can just buy this, plug it in, and get real world signals of a known pattern into your JS220.
Hmm.
So that's the beginning of it. And you don't have to
Okay.
do any programming. You just plug it in and you see some things, and that
So
gives you some real world
it's an
experience.
entropy machine. Is that a fair fair
Sure.
assessment of it?
It generates chaos.
That's right, right. That this thing does, and so does the semiconductor ecosystem.
Oh man,
The
yeah.
purchasing managers.
Actually, it should connect up over the internet and just track your lead times, and that could be the entropy that we
Oh, there you
drive
go.
this with.
Yeah,
Yeah.
right. It just has a little display that says "You're screwed."
Yeah, but this board, the EVK1, is actually a MicroPython board. So it has a Raspberry Pi RP2040 running
Mhm.
MicroPython. So you can actually connect into it, and we have software, little MicroPython scripts that are already on there that you can just configure differently and have it do different wiggles. So it can set different voltages. So we have an LDO and a buck mode power supply. We
Mhm.
also have a bunch of resistors that you can toggle. We have a capacitor that you can actually toggle as well with PWM, and that gives you a bipolar, so it can go plus and minus, so you can see that signal through the JS110 or JS220, and it's just fully programmable with MicroPython, so you can customize it to make it look more like your system and get a off the shelf piece of hardware that you can make measurements on, known measurements, that you can get confidence and then take it over to your real world equipment and see that it's working similarly.
That's awesome. Yeah, I just plugged mine in and got connected to Serial, and it's just ready to go.
Yeah,
So,
yeah, and so you can use anything you want if you're looking to develop it. Thonny, Thonny, is a great little getting started GUI IDE. It's not, I wouldn't really call it even an IDE, but it's an environment for dealing with MicroPython devices, and you can use that to customize these scripts, even just set
oh,
things
cool.
up and play until you are happy.
Python IDE for beginners. That's great. So that sounds like me.
Yeah, no, it's super easy. I mean, that's what I use for doing MicroPython stuff for anything
Uh-huh.
that's not complicated. So part of the manufacturing setup, I've gone all in on Raspberry Pi Picos. So we have,
Oh, interesting.
yeah. So if you're trying to control I/O, digital I/O, it's the simplest environment. So you can just have a REPL, your read eval print loop that's coming out of the MicroPython device. You can actually connect to it with Python on your host computer, and without any work, you have a way of toggling GPIOs with a MicroPython, Raspberry
Yeah.
Pi Pico.
Yeah.
So it's super simple for just things like manufacturing stations where you just want to toggle some lines or read some things in. Makes it super easy.
MicroPython is the new relay logic. Is that what I'm hearing here?
I think so.
Ladder logic, rather. Yeah.
So
That's interesting.
I used to use Arduino a lot for things like this, but with MicroPython, you get the REPL for free. It's more
Yeah.
powerful, and with the Pico, it's $4.
Yeah. The fact that you could just like immediately have it giving feedback without having to like compile and download and that sort of thing is very, very, very nice for fast iteration.
Oh yeah, and then for things that you want to run fast, you write your little MicroPython script that runs on the processor itself and compiles to somewhat native C code. So it's
Uh
it's
huh.
it's not as fast as if you hand wrote it, but pretty close. And
Hmm.
so you can offload things that are fast onto that device, and that's exactly what's happening here. Although we're using the PIO logic
Oh, you
on,
are.
yeah,
Oh,
so
interesting.
we can pump out things super fast. So if you want to toggle these things are very controlled, and you just have the sequence pattern that it just plays out through the PIO.
Huh. How do you find that? I still haven't dug into that. I should have. We've talked about it on the show before, but haven't found a need for it yet. How do you find that? Like, I guess you're writing your own assembly that you've also created the other side of, so it's probably no big deal.
Yeah, I mean, I'm using just again the Raspberry Pi Pico MicroPython code,
Hmm.
and they have a way of just essentially generating that within the Python MicroPython code. So you don't have to even
Oh, okay.
write like a separate assembly file. It's just part of what you get. So it makes it really nice and easy. You do have to know the PIO peripheral. So
Okay.
there
Yeah.
are some things that you need to, but a lot of them you could just find examples online. They're close enough.
Yeah, that makes sense. And then when you're toggling stuff, is it also are you going through like an LC in order to get like PWM to go to an analog voltage, or how are you or does it have a DAC on board, or what are you using to actually get like analog variation?
Okay, so if we're talking about the regulators, I'm actually just setting resistors to get the different voltages, right? So I have
Yeah.
little IO lines that are just connected to one side of the resistor or not, and they're either
Yep.
floating or connected to ground in order to set the LDO regulation voltage or the buck converter regulation voltage. Then on
Yep.
the other side, we have MOSFETs that we're just turning on and off directly from the Raspberry Pi Pico. So that's not analog; it's just digital on or off for those signals.
Yep.
But they're
Yep.
controlling resistors that give you different current values. And then
Ah, okay.
the last
Yeah.
part is the PWM on the cap, and that's just you get what you get as far as voltage, but it's you can control the frequency.
Got it. Yeah. So you basically can kind of toggle it up and down, but you want to have some variation there anyways, right? Because you're not using this for measurement. You're not looking for precision. You're just looking for variation and things that you could showcase, right?
For that case, yeah, the
Yeah.
the cap is not as much of a controlled one as the rest of them are. The
hmm
rest are much more controlled for the resistors, the current loading.
Yep.
But the toggle is just to show something that's harder to get in a controlled environment,
hmm
but is very similar to what you'd see with a switch mode power supply.
Yeah. Yeah. This is a great idea. I mean, like, and I mean, RP2040 has actually been available as well. So, like, just from a
Oh yeah,
availability perspective too, it's crazy,
oh yeah. No, I went out and actually bought 500, and could buy 500. Which was a nice
right?
statement. And I have
You did it just to get that feeling of, oh my god, that's what I remember this.
I remember success when I can
Yeah,
think of
right.
something to build and actually order
The
it.
cart
That
the
was that
cart
was the
actually
telling.
went through. I clicked the button and it showed up my doorstep a couple days later. Huh.
Oh my! I mean, it's an unending source of misery and pain, and just even last night, I was ordering more parts, and this is like a thing I do every day. Oh, well, maybe not every day, but I kind of given up.
Yeah.
So you check all the parts that you need and just go click. And sometimes miraculously, that one day you win the lottery, and TI has them in stock. They
Oh,
they have none
TI.
none yesterday. Yesterday they have 10,000 now, and I'm going to order all of them. So because they
Right.
didn't put a
We're
limit on that
we're
one
like
part.
the junkies at the slot machine, just
Oh my
hoping
gosh.
for that jackpot. You know what? Most days it's a bunch of junk. It's nothing there. There's no cherries to be had.
Unless you want to pay, 10 or 100 times what
Yeah,
the normal
right.
price is. Yeah.
Right. That's called a reverse jackpot.
I've had to do that a few times.
Oh, really?
I'm not happy about it, but the scalper gray market is getting their money now, and they'll
Oh
be in
man.
a world of hurt come hopefully next year
I
and
hope
the
I
year
hope they
after.
I hope they have to eat it. I hope they all crash and burn.
Oh, they're making enough money now that hopefully they're planning
I
for
hope
it.
they
And
spend it on stupid stuff and they go broke.
ugh.
Yeah. Where I guess we should start wrapping up here. Where can people buy one of these?
So you can go to Joulescope.com. We're accepting pre-orders now, and we'll ship by November 3rd. So coming up here in a week from, well, on Thursday. The website is Joulescope, JOULESCOPE.com. You can find us on Twitter for, well, as long as that lasts, at Joulescope. You can find me on Twitter. I'm at mliberty and then the number one, or on LinkedIn, I'm Matt, MATT, Liberty, LIBERTY. You can also, if you have any questions about Joulescope or just low power design in general, you can hop on our forum. We have a great group of people there, which is the forum.joulescope.com. If you go to our support page, you'll get all of this. You can send us a contact email. Really happy to chat. If you have any questions, I'll be checking back with the amp hour here, so I can answer any questions down below.
Oh yeah, we have a comment section as well. I think the
Yeah.
Joulescope forum is probably the best way to do it, but we should send people over there. But if they want to, commiserate about part shortages, the Amp Hour support comment section is the best place to complain about things, as history has told us, and we love you all for it. Anything else we didn't cover about the Joulescope, Matt? I mean, so I should say Matt is super organized, and he sent me like an outline of things that like have been going on and like a timeline. It's just amazing stuff here. So, anything that I missed on here that we should mention?
No, I think we're going to, there's a whole part that is super interesting to some people, the business side of running a company. We talked about a lot of that the
Oh
first
yeah,
time.
yeah,
How do you figure out what product you make?
yeah. Were you on Hello Blink as well? I would imagine that would have been a good place for that kind of discussion as well.
I was, yeah.
Yeah.
So we talked more about finding people for help. So
Yeah.
like my experience with Fiverr and Upwork,
Yeah.
which have been very mixed.
Yeah.
So I actually have had some great experiences on Fiverr and some really bad experiences as well, mostly on Upwork. Actually,
Mm,
I've had
it's
trouble
tough.
there.
Yeah.
Yeah, but on Fiverr, I just had a great experience. So I wanted to get professional pictures of the JS220 because my little
Oh, yeah. Yeah.
white box here doesn't do great with well, I think it might be the operator more than the white box.
Yeah. Yeah. Right. It's not the wand; it's the magician.
Exactly. Sent him out and got him back, and it was an awesome
Oh, that's
experience.
nice.
So there's a whole part there, but maybe another time, and we
Yeah,
can
more
chat more
business.
about
I'm
that.
sure. Did we cover? Oh, we did. We covered the part shortage stuff. Okay, yeah, we got that in here.
Well, yeah, there's always more part shortage
Oh yeah,
complaining and uh,
2025. I'm calling it
oh,
now. That's when it's all going to be worked out. We're going to be like, oh my gosh, I got the cheapest parts from those part brokers, and I asked them for a vial of their tears as well, and they shipped them to me for $20. Uh, well,
uh,
best of luck, Matt.
yeah.
And I really recommend, I'm a Joulescope user. I highly recommend it. And I hope people pick it up and try it out and make better products as a result.
I hope so too, and feel free to reach out to me if you have any questions. And Chris, thank you again for having me on the Amp Hour.
No problem. Let's talk to you soon.